So this video is on stack. A stack is basically a data structure that uses the last in, first out concept. Well, last in, sorry, first out concept. And usually we see that as LIFO. And what that means is I have a structure. So let's think about having sort of like a cup, right? And if I start putting stuff in my cup, let's say I put some balls in my cup. If I start putting balls in my cup, then I'm actually not able to get get the first thing that I put in my cup until I'm able to take the things on top of it out, right? Think of a stack of plates, right? You see this in restaurants a lot where you have a stack of plates. I can't access this plate, right? I can't just go and grab this plate with all the other plates on top of it. I mean, well, I could try, but I would probably make a really big mess. So in order to get to that last plate, I have to take all the plates that are off on the top. And that differs from our array, right? When we have an array, well, one, it's indexed. So if I wanted to get any element inside of my array, all I have to do is just call its index, right? I can just say, all right, give me what's at index 5, and it'll return that element. Well, that differs from a stack. I can't get access to anything else until everything that was put on top of the elements are gone. So a stack is actually a really simple data structure to implement. We actually only need quite just a few functions. The first function that we're going to use would be a function called pop, right? And pop pretty much just takes the first element that's on top of the stack. It will remove that from the stack. So let me just replace that. We actually remove the top element. All right, so that basically, if I have my stack here, and let's say I have these balls in my stack, pop is pretty much going to take this particular element and it's going to pop it out. It's going to take it out of the cup. So now we will end up with something that looks like this. Right, that first element is now gone. The next function that we have is push. And this actually just this puts an element on top of the stack. All right, so let's say we have our cup of balls, and I have 3. If I want to put another ball inside, it will put it at the top, right? And that'll leave me with a stack that looks like this. All right, other functions that we will want to implement would be empty. And empty basically just it's a Boolean function, and it just really tells us if the stack has any elements in it, right? So it's just a Boolean function that states whether the stack is empty or not. Oop. And the secret word is cup. All right, and so basically, if we have a stack that looks like this, then empty will return true. If we have a stack that looks like this, then empty returns false. All right, and so some other functions that we will have will be, of course, size. And this basically just tells us how many elements are in the stack. All right, and uh, finally we have a function called top. And this is different from pop, right? This will tell us what's on top of the stack. And this is different from pop, right? So if I have a stack here, and now let me label the balls since we want to see what's on. So I have 3 balls, and if I say top, or there's 5 balls. If I say top, it's not going to take the ball out of the stack. It's just gonna tell me what the value is of the ball that's on top of the stack. So will not remove the element from the stack. It just returns the value. All right, and so those are kind of the basic functions that we would want in our stack. So of course, we don't want to start developing an entirely new data structure, right? Let's use our linked list, or let's use a dynamic array to actually implement this. And for this class, I actually want us to use our linked list. And so basically, we can create our template. We can create our template stack by using our linked list. So we'll do something like this: class T, and then we'll call it stack. Excuse me, we need to put our class keyword. Class stack. And basically we'll just start putting in our functions. Of course, we will use our linked list as our underlying data structure. So I'll say linked list T, and I'll just call this the list. And then we'll put our public functions, which is going to be, pop, and pop is pretty much going to return whatever data type is of our stack. We will also have push, and we don't really have a return type. This will be push, and it's going to push the data type into our stack. We have empty. And then we have top, which will also return our data type. All right, so this will be a basic declaration of our stack class. Now let's just think about how we would implement. I'm just gonna show pop for example. So if we want to implement pop, we have our return value. We're going to use our class scope resolution, and then basically our function name. Right, so if we're using our linked list, then basically we want to do a few things. So if we're pushing our data at the tail, right? If we're putting the data in our linked list at the end of our linked list, then we actually want to grab the data from our head, right? So if I have my linked list here, right, and each time, well, let me draw it as a linked list. That's more of an array. So if I have my linked list here, And every time I add a node, I'm adding it to the end. Right? Then that means the first n is here, right? This would be the first n. And this would be the last n. And the way the stack works, it says that the last in will be the first out. So if I am going to use pop, that means I want to start by getting what's at the tail. So that means that I would need to actually write a function that will return the last item inside of my list. And not only does it return it, but then it also has to remove that from my list. So we would have to call a function that says, get the value, whatever your list function is. You can say get, maybe get tail, however your function is called. You get tail. Well, we actually want to set that equal to a node, right? We need to pass that. If we're going to return the value, we can just say t value is equal to get tail. And then, of course, we need to get the value. So we can say get value. And then that will get us the value of the tail. Then we need to remove the tail. So we can say list dot remove. And then we can say list dot get tail. And then last thing we want to do is just return our value. So that is a basic, that's basic pseudocode. You may have implemented your list differently, so you want to implement the pop in the way that you implemented your linked list, right? And so push would be the same thing. If I'm pushing to my tail, if I'm going to pop from my tail and I'm going to push from my tail, you want to make sure you pop and push from the same end. And that's basically how a linked list will work. Excuse me, that's basically the way a stack will work. Stack will push and pop from the same end of your linked list. And what I mean by that is if you decide that when you're pushing, you're going to push to the head, right? If you're saying every time you want to push, right, you're going to push to the head, then that's fine. That's your choice. You can push to the head if you want, but then that means that you need to pop from the head as well, because remember, it's last in, first out, right? So that's what I mean by push and pop from the same end. So it's really up to you how you want to implement your stack. All right, and that's basically stack. Some applications that you'll use a stack would be, let's think about, when you're using the undo function. Every time you type something, it puts something in your stack, right? If I type the letter D, and then I say A, and then I decide I want to undo or delete my A, I can put my A inside the list. If I delete my A and then I decide, oh, actually, let me undo that, then I can pop that A back into my my text editor or whatever application I'm using. So that's kind of a basic application. In your book, it explains how you can use a stack to see if parentheses that are open are closed properly. And the way it says to do that is if we have something like x plus 1, right? If we wanted to do something like that, that's something simple, then we will traverse through this expression, and whenever we see a parenthesis, we will put that in our stack. So now I have a parenthesis in my stack. I ignore anything that's not a parenthesis. And then when I see a right parenthesis, then I pop from my stack. So then I will take this out of my stack. And then it says that if you get to the end of whatever you're looping through and your stack is empty, then that means that you have matching parentheses. If for any reason you are trying to push a left parentheses into your stack and you're not at the end of your loop and your stack is empty, then that means that you don't have proper parentheses clothing. And let me just kind of give an example of that. So let's say we have x plus 1 plus, I'll say plus 1 plus, plus 2. So let's say I'm trying to go through that. And of course, this is not a proper closing of parentheses. So let's just go through the algorithm. So it says when you see a left, you push that into a stack. So I'm going to push this left into a stack. All right, so now I'm here. And it says whenever you see a left, you push into a stack. So I'm good. I push the stack. Now I'm here. It's an X, I ignore. Here's X. I'm sorry, it's a plus, I ignore. Now we're at 1, I ignore. Now it says whenever I see a right, then I'm going to pop my stack. So now I see a right, so I'm going to pop my stack. So that means that this is going to go out of my stack. So that means I'm going to go ahead and get rid of the top element of my stack. Now I'm going to my plus, and it says to ignore. Now I'm going to left, and the algorithm says if it's a left, you put it in your stack. So I'm going to go ahead and put that in my stack. Now I'm at 1, then I'm at plus, then I'm at 2, and then it says if you get to a right, you pop. And so now I'm going to pop that out of my stack. And then it says once you get to the end, your stack should be empty. Well, my stack isn't empty. I still have one more parentheses in there. So that means that this did not close properly, right? So let me go over one more example of it closing properly, just so we can see the difference. I'm going to make this one a little bit bigger. So we have x plus 1 plus x plus 1 plus x. And then let's put that all in a parenthesis. All right, so I'm at my left. Left says that I put in a stack. I'm at a left again, I put in a stack. I'm at x, I ignore. I'm at plus, I ignore. I'm at 1, I ignore. Now I'm at a right, so I pop from my stack. Now I'm at a plus, so I ignore. I'm at an x, I ignore. I'm at a plus, I ignore. I'm at a left, so that means I push into my stack. I'm at a 1, I ignore. Plus, ignore. X, ignore. Now I'm at a right, so that means I pop. And then I'm at another right, which means I pop. Now I'm at the end. There's nothing else, and there's nothing in my stack, so that means that everything was great. All right, I hope that makes sense, and thank you for watching.